For these first problems, we're looking for sine, cosine, tangent based on this right triangle given here. For the first ones, we're basing our angle on A. So for sine, since it's opposite over hypotenuse, opposite is 2 root 6 over 5. 2 root 6 over 5. The second one, again based on A, cosine. Cosine is adjacent over hypotenuse. I don't know the adjacent yet, so I'm going to have to solve this triangle using Pythagorean theorem, since I don't know if it's a 30, 60, 90, or 45, 45, 90, or none of the above. So we're going to go 5 squared equals 2 root 6 squared plus, we'll call it A squared. 5 squared is 25. 2 root 6 squared is 4 times 6 or 24 plus A squared. So right away we know that A equals 1. So that side is 1. So now cosine of A adjacent over hypotenuse. So that's 1 over 5. And then finally tangent. Tangent is opposite over adjacent, or 2 root 6 over 1. I'm just going to leave this 2 root 6. The second run here, sine, cosine, tangent, we're going to base it on B, so our perspective changes a little bit. Hypotenuse stays 5, but now our opposite is 1 and our adjacent is 2 root 6. This one's going to require a little bit more simplifying. Sine of B will be opposite over hypotenuse, so that's 1 over 5. Cosine, adjacent over hypotenuse, so that's 2 root 6 over 5. And then finally the tangent, opposite over adjacent, 1 over 2 root 6. So we want to simplify this. We need to multiply the numerator denominator by that root 6 to rationalize. So we end up with root 6 over 2 times 6 is 12. See, sine and cosine just flipped because our perspective, our angle, changed. Second one. Same idea. Now we're working with our special right triangles. Eventually, next year, Algebra 2, this is what you're going to have to memorize or know how to find quickly. Sine of 30, so we go to our 30, opposite over hypotenuse, 1 half. Sine of 60, we go to 60, opposite over hypotenuse, root 3 over 2. Sine of 45, here's our 45, opposite over hypotenuse. It's 1 over root 2, but because we need to rationalize that denominator, we end up with root 2 over 2. Cosine of 30, cosine is adjacent over hypotenuse. No, these are just going to switch. So we end up with a square root of 3 over 2 and 1 half here. Again, basing it on cosine of 60, so cosine is adjacent over hypotenuse. Cosine of 45, it's the same thing. It's still 1 over root 2, but we rationalize that denominator to be root 2 over 2. Then finally tangent. Tangent opposite over adjacent, 1 over square root of 3. We want to rationalize that denominator. We're going to multiply by the square root of 3 over square root of 3. So we end up with root 3 over 3. Tan of 60. Opposite over adjacent is just square root of 3 divided by 1, or just square root of 3. And tangent of 45, opposite adjacent, 1. And finally, for our trick, we've got sine, cosine, tangent again for this triangle, and then cosecant, secant, and cotangent. Those are those reciprocal trig values. So I'm going to go ahead and solve for that hypotenuse side before I do anything else. 1 squared plus square root of 3 squared will equal c squared. 1 plus 3 equals c squared. So 4 equals c squared, or 2. Oh, what do you know? 30, 60, 90 triangle. All right. Now we can go ahead and look to fill in our values. Sine of c, so we're basing everything, all 6 of them, on c. Sine is opposite over hypotenuse, 1/2. Cosine of c, adjacent over hypotenuse, root 3 over 2. And tangent of c see is opposite over adjacent. So we end up with 1 over square root of 3, or the way that we want to write it, square root of 3 over 3. Cosecant. Cosecant is what happens when we take sine and flip it upside down. So I can actually just take this and flip it upside down. That's why it's called a reciprocal tan function. If you remember, cosecant is hypotenuse over opposite. So we end up with 2 over 1, or just 2. Secant is hypotenuse over adjacent. Again, that reciprocal of cosine. So we take that, turn it upside down. We end up with 2 over root 3. Not the best way to write it, so we write it 2 root 3 over 3. And then cotangent is just adjacent over opposite. Almost messed up there. All right, so we're gonna take that and turn it upside down. If I go back to the original, it's a little bit easier, and I end up with the square root of 3 over 1, or just square root of 3.